Hi, my name is Mary Kerr, and today I'm going to be sharing my presentation over the aging and development of the pineal gland. An overview about the pineal gland and what it does. It's located on the posterior region of the epithalamus, and it's composed mainly of pinealocytes, which are secretory cells, which secrete melatonin. It's named due to its pine cone-like shape, and then it's a neuroendocrine loop that begins with the retina. So the retina receives signals of whether or not it's light or dark outside, and that is relayed to the pineal gland, and that regulates the secretion of the hormone melatonin. So the function of the pineal gland, like I said, it secretes melatonin, and melatonin has two main functions in the body. It regulates reproductive hormone release into the body, and then it also regulates circadian rhythms, which play a major role in our sleeping patterns. And the regulation of circadian rhythm is what I'm going to focus on when it comes to the aging of the pineal gland. So an overview on the development. The pineal gland develops from neuroepithelial cells from an invagination of the ependyma covering the third ventricle at the diencephalic-mesencephalic border. It develops in the second month of gestation, and development isn't finished until the fetus is born. So while the fetus is still within the placenta, it receives melatonin through the placenta that is produced by the mother's pineal gland. So here is a photo showing the development of it. It is going to begin with a bit of a bulge off of this diencephalon, and then the walls are going to thicken, and the pineal recess forms, as you can see indicated here by number 2, and then eventually the pineal gland, because it becomes a compact structure containing two different cell types, which are derived from that beginning development. They are going to be the pinealocytes and then the glial-like interstitial cells. And I will explain where those come from. So when the pineal gland first begins to develop, the cells that are present there are mostly PAC6 plus cells, and those divide at the ventricular lumen. And eventually the presence of the PAC6 plus cells decrease, and they're replaced by microglial cells. And the microglial cells remain in the pineal gland to phagocytize any unwanted cells and to make sure things are running smoothly, and any foreign cells that come in are eliminated. And then they also remain there to remodel the blood vessels that supply the gland. So as we age, the pineal gland can begin to calcify, and that's what you see here with this photo. And with the calcification of the pineal gland comes a deterioration in circadian rhythm. And circadian rhythms are the rhythms that affect our sleep and awake schedule. So in many studies, a lack of melatonin, which is associated with the calcification of the pineal gland, is accompanied by a reduction in sleep quality, daytime grogginess, and reduction in cognitive functions. These are some of the sources that I used to create this presentation. Thank you for watching, and let me know if you have any questions.